Today we are going to learn assembler directives. Okay. Now, what is assembler directives? It is also called pseudo opcode. Now, as the name suggests, pseudo opcode. So it is not having opcode, right? The instructions that you are running in assembler all are having opcode. Your control unit will decode that opcode and it get to know that I need to do this thing, right? But these things which are called assembler directives are not having opcode. That's why it is called pseudo opcode. That means these are the keywords which is not actually an instruction, it is just the directives for the assembler. Keep in mind, these are the directives for assembler, not for 8086 microprocessor. They are used to tell assembler something. You want to tell something to assembler, you need to use these directives. There are so many directives available, but we are going to learn limited, right? Which are very useful in your programming. Understand? So in 8086, there are some keywords that you are writing in the program to tell something to your assembler. They are called assembler directives. Clear? Yes? So we'll start with this. There are these two first directives that all of you are using. Segment, right? And if you remember, the first thing that you have done is data segment. And to end this segment, you are writing AND S. S is for end of segment. Yes? If you have seen carefully, this data is not telling the assembler that this is data segment. It just tells your assembler that here is one segment which starts with this location and ends over here. It is logical segment. It is not physical address. No, physical segment. If here I am writing my name sub1 segment sub1 and s, still it will work perfectly. So it is a logical state like segment. It is not data segment, not code segment, nothing. Official segment will allocate later on. Okay, initially this is just a logical segment to tell your assembler that my segment starts here, it ends here. You use these directives. Understand? Yes? Yes. Clear? Okay. Now next is the end. At the end of your code, you are writing end. But if you have seen your code carefully, and always comes with start. Now, why start? Now, start is not assembler directives, it is a label. But you have to write down this label. Why you need this label? The same label will work as main in C. Right? So, what main do? Compiler will first come to main and then start the program execution. Yes? Same way, assembler needs some starting point. That starting point is given by start. So in code segment, you are writing start. So it will give the assembler direction that you need to start execution from this line. That's why you are using start as the label. But it is a label. It is not assembler directive. When you are using and start, it will tell your assembler that your program is now over. Understand? So after and start, your assembler is not going to check anything, not going to execute anything. So here if you write anything, that part is not going to get executed. And what you can write here, the program is developed by me, program is developed in this purpose. So any comment that you would like to write, that you can write after end statement. That is what your end assembler directive do. Clear? Easy? What ends do, what segment and s do. Now this is the directive by which we are telling that this segment which is we have created is now actually a data segment or code segment. There are two ways of doing it. Suppose I have written sub1 segment, some data and s. This is my one segment. It is a logical segment. Currently we don't know it is a text segment, data segment, extra segment or code segment. But in my code segment, move ax, comma, sub1, move ds, comma, ax. If I write these two lines, I am telling my assembler that now sub1 is a data segment that I am going to use. Understand? So here I am allocating this logical address actually a physical part. Understand? Now I am making this as my data segment. Clear? But it is always better to give logically. That's why we are giving data segment, data, and this. Yes? Instead of doing these two lines, you can do the same thing using assembler directive assume. So instead of writing these two lines, if you write assume dx colon supan, it will work. So it will tell your assembler that supan is actually a data set. Understand? And here assume is my assembler directives. So the same thing that you are doing by instruction can be done using assembler directive assume. Understand what assume do? Clear? Easy? Assume will tell your assembler that which logical segment is actually a segment. Yes? Yes. So this part is clear, right? Now, same way you are having functions in C, you are having subroutines in 8086. You can create functions in 8086 also. It is also called procedure. Okay, so if I want to create any procedure, PROC procedure name. Suppose name is XYZ. I am writing my code to end the procedure END P. So it will end the procedure. This is my function definition, procedure definition. Understand? You are having function, you are having function call also. Same way to call this procedure, I am having one instruction CALLXYZ. Understand? Yes. So when my assembler comes on this line, what it will do? It will jump on this procedure, execute this code. When it finds end P, it will come back to the next line. Understand? Yes. If you have remembered our last lecture carefully, every time when you are having a jump, it is called branch. Yes. When you are having a branch, you are supposed to change your IP. What is IP? Instruction pointer. Just for the sake of revision, I am doing it again. Concentrate here. Your IP is instruction pointer which always point to the next line to be fetched. If this is my if statement, these are my code in this if, this is my else part, these are my codes over here, lines written. Now, when this if is in execution unit, my IP will be pointing over here. And at that point of time, there are some lines which are already there in my prefetch queue. So I have already prefetched something. Yes? So this part is already prefetched. Yes? When this line gets executed, I get to know that this condition is suppose false. Yes? In that case, you need to change your IP from this to this because now you need to execute else part. Yes? So your branch instructions force you to change the value of IP. You need to change the value of instruction pointer. Yes? Now, problem is, suppose this is my call statement. Okay? Call XYZ. XYZ is written over here, it is and over here. RET. When you are executing this call, your IP is pointing on this line. Next line, right? IP. But when this call instruction comes, your assembler gets to know that I need to actually jump. So your IP from this line, you need to change it to this line. Here you need to make your IP. So your IP value will get changed. And whenever your end P or return statement comes, you again need to change your IP from this line to here. Yes? Now problem is IP is a single register. So when you change the value from this to this, it will get overwritten. So where you want to come back, you don't know. So we have seen the solution. What's the solution? You need to use stack. You need to push the value of IP onto stack before you jump. So IP lower, IP higher will push onto stack. You will jump over here. When return instruction comes, you again pop this value, put it into IP, you can start your execution. Understand? Just to make you understand easily, whenever you are having a function call, the first thing that your processor or assembler do is store your IP onto stack. After storing your IP onto stack, it will change the value of IP where he wants to go. After executing that part, when return statement comes, it pop the value of IP from the stack and come back on its original execution. Clear? Yes. Every time when you are having a function call or procedure call, you need to follow this thing. Done? Yes. Whatever your procedure do, same thing can be done using macro also. Okay, there is a term called macro. It is also the same thing. Macro, X, Y, Z, and M, you are having some code. It is also a kind of function. If you want to call this thing, you simply need to write down XYZ. You don't need any instruction. You just need to write down the name. Understand? Yes. Then what is the difference between procedure and macro? Why there are two things? Difference is, if this is a function call, our assembler will go over here, execute this part, come back here. When it is a function macro instead of procedure, what happens? Suppose there are 10 lines of my macro. Then these 10 lines will get replaced over here. So my XYZ will get replaced with 10 lines. So I don't need to jump anywhere. I simply need to execute my next line. It will get replaced over here. Understand? Get the difference? If it is a procedure, I need to go there, execute it, come back. Yes, if this is my macro, I don't need to go anywhere. This part will be replaced with that 10 lines. If there are 20 lines, it is replaced with 20 lines. Understand? Both are doing the same. You just need to write down code one time. Right? Which one is better, macro or procedure? Macro. Macro. Why? We don't need to change IP. Good. What is the problem with macro? There are two things. So there must be some advantage of one that is not the advantage of other, right? The thing is, in procedure, as he said rightly, every time you need to change the IP. If you want to change the IP, that means you are actually using branch. If you are using branch, indirectly you are breaking the pipeline. So you are making your process slow. Yes? So procedure is slow. Advantage is procedure only stored once. Right? If I am calling the same macro 10 times in my program, then that 10 line will replace 10 times. It will increase my program size. Yes? If that macro is of 100 line and I am calling that macro 100 times, then 100 into 100. That many lines will get increased in my code, which is a burden to my program. Understand? Yes? So when to use macro and when to use procedure? A very simple solution. If I am calling one function from a loop, then you can use macro, because that loop will be replaced only once. It will get repeated many times. But if you are calling a same function multiple times at different places in your program, you need to use procedure. Then you can save memory. Understand? Procedure is slower, reduce space, use less space. This one is faster but use multiple space. This one is not dependent on stack. You don't need stack, you don't need IP, you will work directly. Here it will dependent on stack, you need to change IP, you will make your branch fail every time. Yes, but only advantage is it is saving your space. You just need to write down code once. Here your code length can get increased multiple times, right? Based on how many times you call it. Get the difference? Okay. Now next is this. This we have already studied. To define a variable, you can use any of these. If I write A, B, B, 55H, in memory, one location will get occupied with 1 byte. Give the name A and we store 55H inside it. Yes? It's a variable declaration. Simple. Right? DB defined byte. It will occupy AB. DW, it will occupy word. It will store in 2 bytes. Yes? DD define double. 32 bits. 4 bytes. Define quadruple is 64. You will occupy 8 bytes in a single slot. Yes? And this is define terabyte, 10 bytes. So 10 bytes will occupy, so total 80 bits will occupy in a single slot. Right? So if I write A, D, T, and if I write F, 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 H, this can get stored in DT, 10 bytes. Very simple. Understand? Yes? Understand? This is nothing to define variables. We can use any of these assembler directives. Again, keep in mind these are assembler directives to tell something to your assembler. They are not executed. Okay? That's why they are called pseudo opcode. Yes? So this is for variable bodies. Then this part is also now EQU. EQU is used to define constant. This one is used to define variables. This one is used to define constant. What is the difference between constant and variables? In variables, variable can change. I know that's why it is variable. Constant can't get changed. That's why it is constant. What is practical implication of that? Suppose in my code I have used a as my variable. Whenever a comes, I need to go to memory, replace the value of a, and come back here. Understand? If you have defined variable, to replace this variable, your assembler need to go to memory, find out the value of a, replace it over here. Every time you need to do that. Suppose a comes 100 times, I need to do this process 100 times. But if I define a as my constant, your assembler are having rights to replace it directly. So if my value of a is 55h at 100 position, at all 100 position, this 55h will get replaced directly. You don't need to change it every time. So the process becomes faster. Understand? Yes? So if you know that in advance that this particular part is going to remain constant, it is always better to use EQ. If you are not sure that the variable that you define is going to remain constant or variable, use it normal variable. Clear? Okay, now next is DUP is my assembler directive. Now what is DUP? DUP used to define array. Okay, so what it will do? A is my variable. DB, I am telling my assembler that I want to occupy 8 bit, 16 bit, 32 bit, how many bits I want to occupy. Array is the size. How many elements I want. Keep in mind, it is not the size of array, it is the size of elements. What that means? If I return DW 8x, 16 bit 8 times, so total 32 bits will get occupied. Understand? If I return DB 8x, only 8 bits will occupy. Understand the difference? That's why you are giving DB also and 8 also. 8 is the number of elements. DUP is nothing but duplicating the elements, right? And if you write down 99h, all the locations will be occupied with 99h. If you don't want to give it, you can put question marks. So all will be taking garbage, whatever is already available, right? So in that case, this question mark is also my assembler directive. Understand? Yes, DUP is my assembler directive, which will help me to decide array, define array. Understand? Very simple. Now next is very important. Align and even. Both are same. Now, I hope all of you know memory banking lecture. What is align? What is misaligned? If two memory locations starts with even address, they are aligned. 0, 1, 2, 3, 4, 5, 6, 7 are aligned. Right? They are on same line. What is the advantage of getting aligned? You can fetch the data in single slot. If they are misaligned, you need to use 2 clock cycles. So 16-bit operation I can perform in 8086 only if it is not like that. If they are aligned, if they are misaligned, still you can do 16-bit operation. But if they are aligned, you can do it in single clock cycle. If they are misaligned, it requires 1 clock cycle for 8-bit, another clock cycle for another 8-bit, right? So 2 clock pulses is required. Yes? Yes. So it will save your 1 clock pulse, right? Yes? So if before defining your data, if you write down align keyword, what your assembler do? Assembler will make sure that your data always start with even location. What is the advantage of that? Suppose if you don't write align, that we are not writing right now, there are 50% chances that your location will start with even address. There are 50% chance that it will get started with odd address. Suppose by mistake it started with odd address. What happens? Every operation requires 2 clock cycles. Yes? Also, a nice example was given that suppose you are listening to a music, like you have stored one full music file. Yes? And by chance you have stored it on odd address. So every time that song gets played, you need to spare double time than it is actually required. Yes? But if you have intentionally write align keyword and store that full song, every time that song will play in half cycle. So in the background you can play the music. So as a good programmer, it is a sign of a good programmer that you make sure that your data structure will start at even address so that it will get run faster. That's why this keyword is useful. Understand? As E1 address should be there. It is also called E1. It is also called align. So before deciding your data in data segment, if you write down align keyword, your assembler make sure that it should start with E1 address. Understand? Yes. समझ पड़ी? I hope so. Next is Bytepedia, Wordpedia. Concentrate here. Move AH, 99H. This is 8-bit operation or 16-bit operation? How you can say that? Because of AH. Move GX, square bracket 1, 2, 3, 4H. 16-bit operation or 8-bit operation? How you can say that? PH. Instead of PX, it is PH. Now, how many bit operation? 8 because it is PH. Understand? So, by seeing the operand, I can say that it is 8-bit operation or 16-bit operation. This will not tell you that this is 8-bit operation or 16-bit operation. From memory, you can access 8-bit also, 16-bit also. Yes? Now, if I write MUL, multiplication, 2, 1, 2, 3, 4, 8. Now, this is the number with which I want to do multiplication. Yes? Now I need to do 8-bit multiplication or 16-bit multiplication. Not sure because it is not written. Yes? Your assembler will get confused. If your assembler will get confused, that will not work. Right? So in that case, you need to tell your assembler that you want to do 8-bit multiplication or 16-bit multiplication. That's why we are using Bytepedia, Wordpedia. If you write down Bytepedia, it will do 8-bit operation. If you write Wordpedia, it will do 16-bit operation. If you don't write anything, by default it will consider as Bytepedia. So if you don't write Bytepedia, still it will work. But if you want to do 16-bit operation, you need to write down mul Wordpedia space your memory address. Understand? This assembler directive tell your assembler that which addressing mode you would like to use. Understand? Sorry, how much amount of memory you would like to use? 16-bit or 8-bit. Complete? Yes. Now org is the origin. Full form is origin. So in data segment, this is my variable A, 11, 22, 33, array B, 22, 44. Now suppose this is written, right? This will be stored by default on location 0. This is on 1. This is on 2. So this must be stored on 3. Yes? We know that. Now I want that this must be stored on location 100. I want to change the starting point of my array B. Intentionally, I want to do that, right? I want to change the offset of my array. In that case, before writing B, you can write org 1000, so it will start on location 1000. Understand? So intentionally, in data structure, if you want your array to start on particular location or variable should store on particular location, you can use org. The origin of data should be a different place that you can do. Clear? Yes. So instead of by default 00, it will start on different location. This is the purpose of org, assembler directives. Then next is near and far. It is used with procedure. Okay, a procedure can be near procedure, procedure can be a far procedure. You have already studied intra-segment jump, inter-segment jump. What is intra-segment jump? Jump within the same segment. Yes. So if procedure is jumping within the same segment, it is called near procedure. If the procedure is jumping from one segment to another segment, it is your far procedure. Why you need to mention near and far? Because if it is a near procedure, we just need to change our IP and that will work. But if it is a far procedure, what do you need to change? If it is a far procedure, you need to jump from one segment to another segment. Segment is decided by CS register. So you don't need to only change IP, you also need to change your CS. So if it is a far procedure, you need to change your CS as well as IP. If it is an intra-segment, you just need to change your IP. Understand? So to tell your assembler that what your assembler need to change, only IP or CS IP, you need to mention the procedure is near or far. Understand? Yes. Next is model. Model is a simple statement which comes as the first line of your program. That dot model small. There are different versions: small, medium, large, even tiny is there. Okay, so by writing this, you are asking memory from the assembler. So once you are writing that your model is small, it will allocate less than 64 KB for your code segment, less than 64 KB for your data segment. Understand? If you are writing dot model medium, it will allocate more than 64 KB for your code, but less than 64 KB for your data segment. Understand? Suppose you are writing a program for microwave oven or your washing machine. In that case, your program is very big. The data is very less. You just need to set the temperature and timer. That's it. But program will be check which food will be there. Dish should get rotated. Timer gets started. It gets to restarted. So the code will be lengthier, but data is lesser. In that kind of cases, you can use dot model medium. We are not going to use it, but still you should know this. If your program is very big, you are doing something for industry yourself, it should be a dot model large. Understand? If you don't write it, still it will work. But you should know this. If it is dot model tiny, everything, data as well as your code will come into 64 KB directly. So it will be a very small, compact code which you can run directly. Done? Now the last assembler directive is offset. I hope all of you remember SI, A. This instruction. Yes? What this instruction do? Load effective address. So if A is my array which starts on location 0005, then what it will do? It will copy 0005 into SI. Suppose A will contain 55H. So 55H will copy or 0005 will get copied? 005. Address will get copied. A DB 55H. A is starting on 0005H. Now this 0005 is my offset. Why it is offset? We are having virtual address. What is virtual address? Data segment colon offset address. Data address will be 16-bit. This will be 16-bit. This is how we store our data address, right? Yes. My address will look like this. This is my offset, and by default it will refer into data segment. Yes. So that's why the 0005 will get copied into SI. If I write move SI comma A, this will copy 55H. This will copy 0005H. Understand? There is a difference between address and data. So what offset do? Offset is doing the same thing as LEA. So instead of using LEA, if you want to use move SI comma offset A. So now instead of giving you data of A, it will give you 0005. So it will do the same task as your LEA do. That's why we have not used it yet, but this is the usage of offset. Understand? Yes? So these are your assembler directives. I hope it is quite clear. They are not instructions, so they are not carrying any sort of opcode which are not yet decoded. They are only used to tell your assembler something. Yes? That's why they are called pseudo opcode. Okay? And each are having some meaning. I hope the difference of macro and procedure is also clear. Which one is faster from macro and procedure? Macro. Which one takes more memory? Which one takes less memory? Which will break your pipeline?
Procedure.
Very good. Then DQ. How many bits will get occupied? 64. Very good. Align and even. Why it is used? To make sure that your program data should get stored on even location. Why even location? So that 16-bit operation will get performed in one clock cycle. Yes? Otherwise, you will get two clock cycle. Memory banking. Yes? PUP array. EQU constant. Why constant? Faster. You don't need to go everywhere in memory and replace it. You can make it directly replaceable. ORG origin. Near far used with procedure. Intra-segment, inter-segment. Yes, only IP, CSIP. Clear? So this is it. This is your assembler directives. Okay?